Alright, start a new section here. We're going to talk about nuclear radiation for the next 3 or 4 days.
We're in here tomorrow. Hey, yo, Davey, Brock. I'm gonna hit you with the sack.
Like, I thought that was so awkward.
Yeah.
I don't get why.
You already know that you watch big friends. You know we ride or die with other people, huh? You already know that's a little bit. You already know that.
It's fine, I know.
You watch it, it's stupid stuff.
Please pardon this interruption. At this time, will the senior homerooms please return the prom king and queen ballads to D214, Mrs. Lewis. Again, please return the prom king and queen ballads to
1852 to
D214, Mrs. Lewis. At this time, thank you.
He lived from 1852 to 1908.
Good morning. At this time, will all Red Cross Club members report to the raft room for the training today? Thank you.
So this guy, Antoine Henry Becquerel, discovered that these uranium salts, that means a salt where the metal is uranium, so uranium chloride, uranium chloride, whatever, they would fog up these photographic plates. So a photographic plate is like film in the old cameras that we used to have before we had a digital camera, and you know, the camera would expose the film to light, and then that picture would be stuck on the film, right? It would get burned into it, sort of. And if you took the film and opened it up to regular light, it would get all foggy because the whole thing would get exposed and there'd be no picture. Well, it turns out the uranium salts did the same thing. And that told him what? It told him the uranium must be giving off something that couldn't be seen. And so this is when people first started to discover radiation. All right, right after that, Marie and Pierre. I spell Pierre. Marie and Pierre Curie. Marie Curie is probably the most famous female scientist of all time. They showed that, what's up? And they showed that rays emitted by uranium
Is there still famous scientists to this day that still discover stuff?
Are there still famous scientists who discover stuff? Yeah.
How come we don't talk about them?
Give me 1 second to finish this sentence and I'm going to tell you. Alright, so they were able to show that there were rays being emitted from the uranium, and that's what caused the plates to get fogged up. Alright, to answer your question, everything you study in high school was discovered mostly before the year 1900. It's all old stuff, because the stuff that's been discovered in the past 100 years is really complex, advanced stuff that you study in college. There were a lot of famous people in the 1930s who developed quantum mechanics. There was a famous guy in the 1960s who worked on similar stuff. There are famous people today, but the stuff that they are discovering, none of us understand. And when people understand it 50 years from now, they figure out if they're right or wrong, then they'll start teaching it probably at college or graduate school. People discover cures for diseases. That happens, right? And new medicines. But maybe the answer is that there's so much research going on that you just don't get famous for it anymore. I don't know if that's helpful or not. All right. They called these rays what do you think they called them?
Rays?
No, they call it radiation. So there you go. This term comes about. Now remember, not all radiation is dangerous, but the stuff we're talking about the next couple days is the dangerous stuff. All right. One more. Nuclear radiation. That's what we're focusing on right now. Nuclear radiation happens because of changes in the nucleus. Things happen in the nucleus. A proton turns into a neutron, or a neutron turns into a proton, a particle is given off, or the nucleus breaks into two pieces and something's given off, things like that. These things create radiation. Alright, off to the side somewhere, actually no, you know what? I already gave you that, no. We're just going to start this. Alright, if everybody has this, I got to erase it. Everybody caught up here? Alright, good. Alright, so let's talk about the three types of radiation that we're going to go over the next few days. There's obviously more than three, but these are the three that are dangerous, and these are the three that are nuclear. Alright, alpha radiation. So these three types are named after Greek letters: alpha, beta, and gamma. Beta should really be beta, but you know Americans, they can't say anything right. So alpha, an alpha particle is just a helium nucleus. Basically, some atom shoots out of its nucleus, two protons and two neutrons stuck together. Those four particles in one piece, that's an alpha particle. It's a very large particle, and because of that, it's actually very easy to stop it, because it's going to bang into atoms as soon as it's ejected. So, where am I at here? So this is one of these things you want to know about each of these types of radiation. What does it take to stop it? So how do you protect yourself if this radiation is going to get off? So, alpha particles can be stopped. By a piece of paper. So when it comes to alpha radiation, if you're in a different room, if you have clothing on, anything will protect you. Because it's such a big particle, it's just going to be attracted to the nuclei of other atoms. It's going to bang into them, it's going to stop. Where am I here? Alright. Now, let's look at a reaction. So you know we do chemical reactions for all the, you use equations for all the chemical reactions I showed you. Same thing for nuclear reactions. I can make it look like an equation. So here is one. Uranium, 92, 238. Alright, so mass of uranium is always 92. This particular the atomic number of uranium is always 92. The mass of this particular isotope is 238. The uranium goes through an alpha decay. So think about this, right? This is the atomic number. That's the number of protons in the uranium atom. if it gives off an alpha particle, how many protons is it losing? Well, what's an alpha particle? I just told you. It's a helium nucleus, right? It's 2 protons, 2 neutrons. So if it gives off an alpha particle, it's going to lose 2 protons. So whatever the new element is, it's going to have an atomic number of 90, right? And now you just look on the periodic table, you go 2 back from uranium and it's thorium. So anytime there's an alpha particle given off, whatever the atomic number of that element is, it drops by 2. And then the alpha particle has a mass of 4, so this is going to go down by 4, 2 protons, 2 neutrons. So the mass is going to be 234. Plus your alpha particle, which we're going to represent this way as helium. And there's no electrons, right? Just the alpha particle itself. So this is a reaction where an alpha particle is given off, that's your alpha. All right, beta particles, beta radiation. Beta particles are either electrons or positrons. You all know what an electron is, right? What's a positron? It is the antimatter form of an electron. So it's the opposite of an electron. It has the same mass as an electron, but it has the opposite charge. All right. Let's show a reaction that does, oh, how do you stop it, right? So, beta radiation can be stopped by a wall, something reasonably thick, you know. It doesn't have to be lead or concrete, just not be in the same room, basically. And with alpha, you can just wear one of them suits that they wear in the movies, right? I mean, there's any kind of suit that covers real much. Beta, you would want a couple inches of thickness, a door between you, anything. All right, here's a reaction where beta is given off. Carbon-14, you've heard of this isotope, right? That's the one they use to date things. A couple thousand up to 20,000 years old maybe. So what this does, it gives off an electron. Now remember, this is nuclear radiation, so the electron comes out of the nucleus. So it's kind of strange. What actually happens is the neutron gives up a negative charge, so the neutron becomes positive. So it turns into a proton. Right, so that's what's happening, which means the atomic number goes up by 1. One neutron turns into a proton, so the atomic number goes up 1. So the atomic number is going to be 7. What's that element going to be? Nitrogen. Now, since the total number of particles in the nucleus stays the same, just one of them turns from a neutron to proton, the mass stays 14. It doesn't change. And then the particle given off is the electron. So this is your beta particle. Now, if I showed you a reaction where a positron was given off, it would be the opposite. The atomic number would go down by 1. All right, one more and we're done. What are these last ones going to be called? Come on, the first 3 letters of the Greek alphabet.
Sigma.
ABC.
Zeta.
C, that's right, ABC. Did you guys watch Incredible Hulk or whatever? Gamma radiation.
Honestly, Hawks were the worst. Actually, really good.
Yeah. Gamma, radiation, let's say bits. I don't like the way I worded this. Photons. Photons are electromagnetic, right? Stuff we already studied earlier in the year. The EM waves. Light, and so on. What do we know about photons? They have no mass, right? Because they have no mass and no charge, they go through most stuff. Some photons can go through the whole Earth, other ones can randomly bang into things. So, because of that, difficult to stop. So thick lead walls or several feet of concrete. Stop some of this. Some gamma rays are always going to get through. Impossible to stop all of them. But this is the kind of stuff where you need to be underground, trying to get away from them. All right. Let's see. First reaction. With thorium. Thorium-230.
Have you ever seen that movie, Journey to the Center of the Earth?
Yes.
That's an awesome movie.
I thought it was Alright. Thorium-230 decays. Okay, so here's a reaction. It's going to give off an alpha and a gamma. Turns into radium 88-226 plus an alpha particle plus gamma ray. So sometimes you get more than one type of radiation given off at the same time. Alright, tomorrow I'll talk more about what causes things to be radioactive. It has to do with the number of neutrons versus the number of protons in the nucleus. Actually, not tomorrow, because tomorrow's the prom, but whatever the next lesson is. Questions on any of this?
Monday.
Monday, probably Monday. Neil, would you add it to it? Yesterday my camera shut off twice.